Welcome back. I'm Professor Steele, and today we're going to look at some thinking problems involving our exact values. First problem asks us to determine the cosine value of 240 degrees. As always, try and visualize what that means. So 240 degrees would be going around our circle at least halfway. This is the unit circle. That would be 180 degrees. And then think about how many degrees beyond that we would have to go. So if this is 240 degrees, our reference angle, remember, is the smallest angle created by the ray and the x-axis. So our reference angle happens to be 60 degrees. Cosine, again, recall, is the horizontal distance created by the arc subtended by that angle. We have this horizontal measurement of 60 degrees. So cosine of 240 degrees would be equivalent to cosine of 60 degrees. However, it is a horizontal measurement and we're moving in the negative direction. So it's negative cosine of 60 degrees. And if we recall, our cosine of 60 degrees is 1/2. Moving on, sine of negative 420 degrees. From our positive x-axis, we are now going to go clockwise. So one full revolution is 360 degrees. We need to go a little bit beyond that. In fact, we're going 60 degrees beyond that, which is again our reference angle. So sine of negative 420 degrees is equivalent to sine of 60 degrees, being the vertical measurement. And if you recall, sine in this quadrant is negative because our vertical measurement is below the x-axis, and sine of 60 degrees is radical 3/2. And again, if you've drawn your diagram, you should be able to ask yourself, does that look reasonable? Yes, radical 3/2 is roughly 0.8 something, so does it look like I have a vertical measurement of 0.8? In the next two problems, we're asked to determine what is the angle whose cosine is 0.5, and what is the angle whose sine is negative radical 3/2. The angle whose cosine is 0.5. So the angle whose horizontal measurement is 0.5. If we go horizontally 0.5, we have two rays that we can create with an angle. We have a ray in the first quadrant, and we have a ray in the fourth quadrant. So the question is, if we have a horizontal value of 0.5, what is this angle? The angle that gave us the horizontal measurement of 0.5 was 60 degrees. However, it's not only 60 degrees. We can go all the way around to this fourth quadrant, which would give us 360 minus the 60 degrees. So we have two angles, 60 degrees and 300 degrees. If we didn't have a limitation on the angle domain, we could continuously go around to determine other angles. Sine of negative radical 3/2. Again, our vertical measurement is this time negative 3/2. That tells us which two quadrants is this in. Pause and take some time to think about that. So negative radical 3/2 is our vertical measurement. So we're roughly in this zone, some point that has a vertical measurement of negative radical 3/2. So the two rays we can create give us either this angle or this angle. If we think back to our exact values, with our right angle being here, our vertical measurement of radical 3/2 matches up with our reference angle of 60 degrees. However, we want the full angle that takes us around to that reference angle in the third quadrant. So that would be 240 degrees in our third quadrant. In the fourth quadrant, this would be our 60 degrees. So we want 360 minus the 60. So we're looking at 300 degrees. Recall that this is quadrant 1, 2, 3, and 4. The negative sign values as well as the positive make a difference when you're talking about horizontal and vertical measurements. I hope this has helped. We'll see you next time. Please make sure to like and subscribe to EdVantage.